Lesson 3.2, Complex Numbers. In complex numbers, we have something called the imaginary number. Now, it's a terrible name. It's not just completely made up. It's just what they unfortunately named it. We have real numbers and imaginary numbers. But they're both numbers. It's not like one exists and the other doesn't. They both exist. Imaginary number is I. I is the square root of -1. Before we said we couldn't take a square root of a negative. Well, now we can. If you have square root of a negative, it is I. And I squared is -1. Those are the two most important things to know for complex numbers. Whenever there's a square root of a negative, it becomes I. Whenever you have I squared, it becomes -1. For example, a square root of -9. Well, that would be the same thing as the square root of -1 times the square root of 9. Square root of -1 is I. Square root of 9 is 3. We usually put the letter last, so that would be 3I. Or the square root of -12. Be square root of -1, and then 12 is 4 times 3. So the square root of -1 is I, square root of 4 is 2, and then we don't know the square root of 3. And again, usually we put the letter last, so it would be 2 square root of 3, I. Or some people put the I before the square root, 2I square root of 3, but it's the same thing. Complex numbers are both real and imaginary numbers. So if you have real numbers, which are all the ones we dealt with before, imaginary numbers, which have the i's, complex numbers are the combination of both of them. Imaginary numbers are any number with an I. Real numbers are any numbers without an I. When we combine them, you get something in the form of A plus BI. We're supposed to find the values of x and y that satisfy this equation. Now, if these are equal to each other, the real parts would have to be equal to each other. So the 5x would have to be 35, or x would have to be 7. And the imaginary parts would have to be equal to each other. -20i would have to equal yi. Well, we can see if we divide by I that y is -20. And now that we know what complex numbers are, we can add and subtract them. I behaves like any other letter. Therefore, when we add and subtract, we're going to add and subtract the same way as you do this one, where you'd say, oh, I have 1x and 2x makes 3x. 4 and -3 make 1. Same idea. We are simply combining like terms. So here's one. Let's combine the real part. So the -1 plus 3 is 2. And then combine the i's, the imaginary parts. 2i plus 3i. 2 plus 3 makes 5i. And that's your answer. Let's try another one, this time subtracting. Let's start with the real parts. 2 minus 3 is -1. And then I have -3i minus a negative. Oh, minus a negative is like a plus. So I have -3i plus 7i. -3 plus 7 is 4i. One more. Do it the same way, even though there's 3 things. Collect all the real parts. That's a -3 plus 2. -3 plus 2 is -1. And then I have 2i minus I would be 1I plus negative 3I. So 1 plus a negative 3 would be minus 2I. All right, now let's try multiplying complex numbers. It's just like multiplying binomials. You'll do FOIL method, first, outer, inner, last, or the distributive property. The thing to remember is I squared is negative 1. So every time you have an I squared, change it to negative 1. All right, so here's our first example. I think we can just distribute here. So I'll have negative 1 times 3, negative 1I times 3, be negative 3I. And then I have negative I times I. Well, I times I would be I squared. But I squared is negative 1, so replace that with negative 1. Negative times negative is positive, so it'd be plus 1. And we write it with the real part first, the imaginary part second. So it's 1 minus 3I. Let's try another. Okay, let's distribute. 2 times negative 6. 2 times negative 2I. 3I times negative 6. 3I times negative 2I. Now the I times I makes I squared. Go ahead and change that to a negative 1. So it'll become a plus 6. So negative 12 plus 6 is negative 6. And then I can combine those. Negative 4I and negative 18I is negative 22I. And then our last one. We'll have 1 times 1. 1 times negative 2I. 2I times 1. And 2I times 2I are negative 4I squared. Because the I times I makes I squared. I squared is negative 1. So that'll become like a plus 4. So I'll have 1 plus 4. And then I have negative 2I plus 2I, which is, they cancel out, 0. So our answer is simply 5. Notice on the last example, the answer was just real. That example was complex conjugates, which are the same numbers, just the opposite sign on the imaginary part. And it turns out when you multiply complex conjugates, the product is real. So complex conjugates would be like if I had 2 plus 3i, the conjugate would be 2 minus 3i. Everything's the same except for the sign in front of the I is opposite. So one's a plus and one's a minus. When you multiply those, the i's will cancel out and you'll be left with just a real number. That'll be good to know later on. We do have some solving. Notice, to solve this one, the x squared is the only place where there's x, so you could probably solve by taking a square root. So I'll subtract the 121. So x squared equals negative 121. And then I'll square root. Don't forget the plus and minus. So x is plus and minus. The square root of the negative is I, and square root of 121 is 11. So x is the plus and minus 11i. Let's try one more. Again, the x squared is the only place we see x, so we can move everything away from that x. Subtract 25. So we get negative 441. Divide by the 3. So we get negative 147. And then we square root. Don't forget the plus and minus. All right, we'll have to figure this one out. All right, so we have the square root of the negative, and then 147 turns out to be 49 times 3. So the square root of the negative 1 is I, square root of 49 is 7, and the square root of 3. So x is plus and minus 7 square root of 3 I.